Hello everyone, today we are going to discuss another LeetCode problem of the day, and the name of the problem is binary prefix divisible by 5, and it is marked as easy on LeetCode. So first we read the question, then we will move to the approaches. Question says, you are given a binary array nums 0 indexed. We define xi as the number whose binary representation is the subarray from most significant bit to least significant bit. For example, if nums is equal to 101, then x0 is 1, x1 is 2, x2 is 5. We have to return an array of booleans answer where answer of I is true if xi is divisible by 5. Okay, so question says that we are given an array nums which store either 0 or 1, and x0 denotes the number whose binary representation is the subarray nums from 0 to I. That is, x0 represents the subarray of nums I, subarray of nums I from 0 to 0. x1 denotes the subarray of nums I from 0 to 1, and x2 denotes subarray of nums I from 0 to 2. So it represents from 0 to 0, it's 1 in the provided example. From 0 to 1, it's 1 comma 0, and from 0 to 2, it's 1, 0 and 1. Okay, so when we convert these binary numbers into the decimal one, then we have to check whether that output is divisible by 5 or not. When we convert x0, then in decimal it is coming out to be, in decimal, binary decimal of the decimal representation of single one is 1 only. The decimal representation of 10 is 2, and the decimal representation of 101 is 5. Okay, so is it divisible by 5? No, it's not divisible by 5, so we return false in that case. Is it divisible by 5? No, it is not divisible by 5. Then we return false in this case. Is 5 divisible by 5? Yes, it's divisible by 5. So our answer array in this case would be the false, false and true. So this is our final answer array for this. Okay, so let us move into some examples so that we can understand the question more clear. Okay, so another nums we are given is this, and the size is 3. Okay, so here the x0 would be 1, x0 would be 0 only. Here the x1 would be the subarray of nums from 0, from index 0 to 1, that is 0, 1. And x2 is the subarray of array nums from 0 index to index 2, and it's coming out to be 0, 1, 1. When we convert it into the decimal, so it's coming out to be 0, it's coming out to be 1, and it's coming out to be 3. And we have to check whether it is divisible by 5 or not. Is 0 is divisible by 5? Yes, it's divisible by 5, so it's true. Is 1 divisible by 5? No, it's not divisible by 5. Then we return false. Is 3 divisible by 5? No, it's not divisible by 5. Then we return false. So this is our final answer array that we have to return in this particular question. Okay, let's move into another example. And the nums is given to us this. Here when we find x0, it's coming out to be 1. When we find x1, it's coming out to be 1 1. That is from index 0 to 1. And when we find x2, it's coming out to be 1 1 and 1. When we convert it into the decimal, then its decimal is 1, its decimal is 3, and the decimal of this much is 7. We have to check whether it is divisible by 5. No, it is not divisible by 5, so we return false. Is 3 is divisible by 5? No, it's not divisible by 5, then we return false. Is 7 is divisible by 5? No, it's not divisible by 5, then we return false in this case. So our answer array for this example would be false, false and false. Okay, so I hope you all understand these two examples. So let us move on to the approaches of this question. So very first approach that came to our mind is the brute force approach. Okay, so what basically we are going to do in the brute force approach? So we are going to traverse the array from left to right, and we are initializing a string, and for every character that we get, we simply append that particular character to the end of the string, and then inside that loop only, for every string that we get, we have simply apply one more function called as converting binary to nums. Converting binary to nums. Converting binary to nums. Binary to nums. So okay, let me give you the code template for this particular brute force approach. For here, we are going to run a loop from I is equal to 0 to n minus 1 index, and at outside we are initializing a empty string, and for every character that we get, we simply append that particular character in our string s by casting this particular numsci in the char by okay, and then we run additional function that convert our current whatever is inside the string s into the decimal. We get int the answer. When we run the particular function, then we get the output in our answer, and then we check whether my answer is divisible by 5. If it is divisible by 5, then we put true in our answer array, else we put false in our answer array. Okay, so talking about the complexity of this brute force approach, it's order of n square, and the space complexity here is order of n, that is to store the answer only, to store the answer, to store the answer. Okay, so this is our brute force approach, and so this brute force approach gives TLE. This brute force approach gives TLE because the constraints for the n is less than equal to 10 to the power 5, and for n square it's approx 10 to the power 10, 10 to the power 10 operations. So it will for sure gives us the TLE. So I think we need to think for some better approach, some optimized approach. Okay, so first we will visualize one thing. Okay, so suppose we are given a nums array 0 1 1 0 1 1, and we need to traverse from left to right. Okay, initially when we traverse we have only 0. Okay, so the decimal value for this is 0. When we reach to this index, that is index 1, then what we have to do, we have to append one bit to the left of the current bit. So exactly what we are doing is we are left shifting our current value. We are left shifting our current value by 1 and appending either 0 or 1. Okay, what we are doing, we are basically doing the left shift of the current value or the current decimal representation of particular number to left by 1 and appending either 0 or 1, that is the current bit. If it is 0, then we append here the 0. If it is 1, we can append here the 1. So if we have to find out the what the value of this particular is, we can find out whatever my previous is. I simply done it left shift by 1, simply the left shift by 1 and adding what is the current value or the current bit that we have is. Okay, so this will give me the decimal value of this particular binary. Similarly, for example, in this case the previous would be the 0. Okay, when we left shift 0 by 1, what we would get it, its answer is 0 into 2 ka power 1 and it's coming out to be 0 plus the nums of I would be 1, the nums of I would be 1 and it's coming out to be 1, and then we would check whether whether my previous is divisible by 5 or not. In this case my previous is coming out to be 0 because we are going to initialize the previous as 0. Okay, so what, when we evaluate this for 0th index, then we get 0 left shift by 1 plus, and the current bit is also 0 and it's coming out to be 0. Is 0 divisible by 5? Yes. So for 0th the answer is coming to be true. For x0 we can say. For x1 when we evaluate, it's coming out to be 1. Is 1 is divisible by 5? No, it's not divisible by 5, so we return false. Okay, let us move to the third bit, that is index number 2. So initially we have 0 1 and till this time we have the previous as what, we have the value previous as 1 and we are appending one more bit at the last, that is the current bit, that is 1 here. So what we are basically doing, we are shifting previous value to the left by 1. Okay, and we are appending 1 at the end, that is current bit. So previous that we would have till this is 1, and when we will left shift by 1 plus, and the current nums of I that we have is 1. When we do 1 left shift by 1, it's nothing but 1 multiplied by 2 plus 1 and it's coming out to be 3. Okay, so now we have to check whether my 3 is divisible by 5 or not. So 3 is not divisible by 5. It's not divisible by 5. So in that case we have to simply return false. So I hope you all get this particular example, and now you all are able to easily code the solution for this particular problem. So it's nothing, it's very simple. What we have to do is at every index we need to left shift the previous value by 1 and adding whatever the value of current bit. If it is 0, then we add 0. If it is 1, then we add 1, and then we would check whether my previous is divisible by 5. If my previous is divisible by 5, then I'll be inserting true in my answer array, and if it is not divisible by 5, then I put false in my answer array. So I hope you all are getting this particular example. So if we move on to the code, okay, so let me write the code for you. Okay, so let us move on to the code. Okay, so code is basically we have to return a vector of boolean. Okay, I don't have the exact signature of the answer function, so let us suppose it's a solve function. And we are provided with a vector of bool that's nums. Okay, so what we are going to do in this particular example is we are simply initializing a variable called previous so as to store the decimal value of the previous bits. Then we are simply going to traverse. Okay, before that we are going to initialize our answer array vector of int answer, and it's initialized to n. It's not integer, it's a boolean array because our answer array is boolean, and we need to find the value of n also. Okay, so after that what we are going to do, we are simply going to run a loop from I is equal to 0 and for this we are going to find the previous value as previous, left shift the value by 1 and adding the value of the current bit. And when we are getting the value of previous, we have to perform mod 5, and after this I need to push answer of I is equal to the value if my previous is equal to 0. If whatever my previous after modulo 5, if the previous is divisible by 5, my previous value would be 0, and if this condition is true, my answer of I would be equal to the 1, and if this condition is false, my answer of I would be 0. Okay, and finally we are going to return the answer. Okay, return the answer array. Okay, there is some typo error, let me correct that. Okay, so this is the solution for this particular problem, and this is the optimize the solution. And if we have to talk about the time and space complexity for this particular solution, the time complexity, as you all are able to see, it's order of n, because for only once we have to run or we have to traverse the entire array nums. And talking about the space complexity, it's order of n, or we can say order of 1, because n space is required to store the answer only. Store the answer only. Storing the answer. I hope you all understand this particular problem. If you have any doubt related to this particular problem, then you can tell me in the comments. I'm happy to answer all your doubts. Thank you everyone.